I'll be just presenting the capabilities we have as a group. I didn't prepare any project proposals. We're in several European projects, also with Kevin, in two actually. So one I wrote and one Sintef in Norway wrote. So just briefly go through what we can do, and maybe there's some things we can do. So essentially there's two things. There's the Centre for Fuel Cell Hydrogen Research, which is the university itself, School of Chemical Engineering. It's about 40 students and 10 staff in that group, and we cover a broad range from hydrogen production, storage, both together with other schools, so that would be MET and MET. Low temperature fuel cells, high temperature fuel cells, I'll be going through that. We have quite an interdisciplinary approach because we work with other schools. And the reason for that is we have this Centre for Doctoral Training, or now it's called Doctoral Training Centre. As from 1st of April, it will be Centre of Doctoral Training. It's been extended by another 9 years. So we have had a total of 50 students together with Loughborough and Nottingham. Now we've included Imperial College and University College in London. And again, we'll be having 50 students plus 25 we fund ourselves. And they're going through a 4-year program where we have 1 year of orientation and 3 years of concentrated doctoral studies, again, across this broad range. So that kind of blends with each other. So hydrogen production, we have low temperature electrolysis, specifically looking at corrosion. We have high temperature electrolysis with SOE, so solid oxide electrolyzer, where we're looking at developing the cells ourselves, Scania-based, and working from there, so getting very high efficiency processes. Together with the metallurgy and materials people, we are also looking at metal hydride storage. So we're looking more at system sites, they're more at the materials. Focus we have is production of hydrogen from biomass, whatever, including supercritical water gasification. And also some work on natural gas or propane before we. And I have a project going on looking at how you could use as storage for photovoltaics and other. Low temperature fuel cells, so in situ, ex situ characterization, development of platforms that with which we want to achieve a reduction in platinum, amount of platinum we use for the electrode. Alloys is another thing, or things that don't contain platinum at all. We can manufacture things up to an MEA, including the bipolar plates, which is one of the projects we're running with MIBA, or we as MIBA. But that's one at the moment at least. So we're both active in base fuel cells, and then we're also working in what we call intermediate temperature, which is as opposed to the high temperature PFC, which would be running at 160 or 180. Monoxide sensitivity, we're looking at operating with the water management, because all the water would be in double flow. Good question. So, and we're specifically also looking at gas diffusion layers, because that's something looking at much at the moment. So also bring in things like gas distribution, as we have solid oxide fuel cells, high temperature fuel cells, into lower temperature fuel. Sorry, going the wrong way. We don't work on stacks, but we do work on systems, specifically integration of systems into our road vehicles. So we helped Microcab with their Mark I, and did the integration at Birmingham, where it was before I joined. I wrote the Swarm project, which is now being equipped with, and we are kind of helping by employing the vehicle. With Airbus on unmanned aerial vehicles, well, actually lives on a boat. Has got a Rex Harris one, and another topic, the electronics department. High temperature fuel cells, as the microtubular ones Kevin Candle started. Now we're moving towards planar SOC. It's reason more compact, much more stable. The microtubular part for the rapid startup, very small scale. So I'm pretty sure what was shown today as a 10 watt kilogram, we can do that with 2 tubes. Well, here again, looking at specific topics like what happens when the anodes use, supplying the fuel, for instance, taking exactly this biomass-derived fuel, putting it directly into this top, whether it's syngas from gasification or fermenting or digestion. specifically looking as a means of increasing the conductivity and especially building 100% starting from anode substrate, making the cells ourselves with finally applying all the layers to be able to understand the production process to make our signals. Our own samples, being able to integrate our own materials. And then also we have a number of studies going on, especially in the doctoral training center, so also in Loughborough, where we're looking at public acceptance at cost, where we're looking at integration into larger systems like the renewable energy integration, social access, understanding the fuel cell market uptake, specific at the interjection at the other meeting, where specific fuel cells, with kind of recognizing what their higher value is, not just trying to replace vehicles or trying to replace a heating system. That's not what you're marketing here. You're doing something else. That's a British Gas. Well, I don't know. Hopefully be out of the market in 20 years because they have no customers anymore. And lots of small companies to sell this and really give the customer a benefit and make their profit of this. Because I believe these large companies, they just can't think straight. They don't understand. Environmental impact assessment, a couple of things going on about whatever energy, including also this food buy debate, which is a non-debate as far as I'm concerned. So what happens if the platinum nanoparticles actually leave the fuel cell in the environment? Right, that's not Vitek sadly died a year ago. So, well, with one of the microcaps, we still have two. So we have quite a bit of capacity. One or two of my students are working on elaborating proposals that are not the joint undertaking. There's two calls on electric vehicles this year and next year, where we would be looking for companies building small vehicles, electric vehicles. And one call is on battery system development, the other on, I can't remember. So everybody's in this area, subtropical I heard today, or Ostrava too, I know. Please get in contact with us and we'll see what kind of a proposal we can come up with. Preferably, of course, it would be industry, because as a university, I mean, you can't go ahead and commercialize these technologies. Good, yes, you'd have to ask me for my contact details. I forgot to put them on. Yes, I have to give you a business card.
Okay, yeah, thank you very much, Rob. I'd like to introduce Kevin Cooke from Teer's MIBA Group. Kevin.
Thanks, Alex. Thanks very much for the invitation. I'll try a brief flavour of the sort of things that we can do. So the takeaway message from this is we're doing vacuum coating, so it's vacuum deposition. And it's also thin. We work in the range of coatings from, say, 50 nanometers up to a few microns. So that's what I want you to sort of, the areas I want you to think about. In the centre, we've just got one example, which is a bipolar plate, typical geometry, where we can put a coating down onto the bipolar plate to improve conductivity and corrosion resistance. On the left-hand side, the image of that is a typical batch coating system, where we put the work in, the plates to be coated, for example, pump it down, coat them, take them out again. On the right-hand side, we've got the next stage on from that, which is a semi-continuous processing system, where you have load locks either end to take work in and out of the vacuum, multiple vacuum chambers so that you can deposit coatings in sequence as you go through, and that unit will produce work every few minutes, depending on whatever the longest cycle time is for the particular part of the process. So anything from a few hours floor to floor to a few minutes floor to floor. That's the sort of scale we can work at, and that's the sort of areas we're looking to exploit. Right. Next one. So again, just to give you a flavour of the sort of things we can do, so this is putting thin film coatings onto metallic bipolar plates for PEM fuel cells, obviously a very popular area, and one where we're in an actual current FCH-JV that's looking at that. On the bottom left, it's just showing how you can improve the corrosion characteristics of stainless steel by putting on the appropriate coatings onto the surface. On the right-hand side, we're looking at how you can improve the electrical conductivity, so decrease the interfacial contact resistance of stainless steel. It's a log scale there, so the basic stainless steel itself you've got the passive layer on there, so it's not very conductive, unfortunately. If you put coatings on there, you can rectify that situation. You get very good conductivity and also improve the corrosion resistance. The class people look at first, of course, is gold, but even at 20 nanometers or even at 10 nanometers, gold is far too expensive for the large-scale application in the automotive market. So we're looking at alternatives, things like titanium nitride, which is ceramic, inert, but electrical conductive, or this one, which is a carbon-based coating, a commercial coating that we offer, which is getting down into the similar conductivity of gold, but is obviously much, much cheaper. So it's just to give you that flavour. That's one area where we can work, putting a continuous coating onto something like a bipolar plate. The other area we can work is in catalysis, electrolyzers. So normally we try and make a perfectly flat coating, a perfectly conformal coating. On the left-hand side you can see something that's completely different. This is what we call a high surface area coating. We've adjusted the coating conditions deliberately to create those large areas of growth with these multiple nucleation sites to produce this very dense structure with high surface area. Much more effective for catalysis. That's very effective in things like electrolysis. And this is some results from actually a UK collaborative project that's showing, in this sense, moving to the right-hand side is good. In this sense, you're getting more efficiency out of the cell. So moving from a classic nickel plain electrode, which is the black line, moving towards this, the red line, which is a high surface area nickel molybdenum, and you're getting much more efficiency out of the cell. You can get higher hydrogen production for a lower applied voltage, for example. So that's what we can do there. So we can basically tailor the structure of a surface by applying whatever coating we need. So what do we want to do with these facilities? We're interested in moving towards higher volumes, large areas of functional coatings. So that's things like electrode plates, interconnector plates for solid oxide. We're already active in projects in those sort of areas, but for the future it's going to be how to address things like scale up, because that's what we've heard today. Everything is about getting costs down in the future. It's relevant to PEM, it's relevant to direct methanol, it's relevant to electrolyzer, it's relevant to solid oxide. So it's right across the spectrum of hydrogen technologies. We're interested in manufacturing supply chain issues where people want to work with us, looking at the implications surfaces have for other manufacturing processes. So if we put a coating on, what does it do to subsequent forming technologies? What does it do to moulding technologies? What does it do to welding, laser welding or cutting that you want to do on a coated plate? A bit of a tangent, but we can put coatings onto tooling. That's our bread and butter business. That's what most of the company does. Fuel cells is our investment for the future, but today's technology, coatings on cutting tools, coating on forming tools. If you put coating, a specialist coating onto a forming tool that's then used on a coated material that's used in a hydrogen device, can we get better properties? So I'd say a bit of going off at a bit of a tangent, but it is relevant. Scale up and cost down I've already mentioned, so factories of the future type situations. How do you integrate all these processes together to get the best possible functionality and lowest costs? Process modelling, simulation. So the partners we need, definitely end users, because that's where the impact comes. We're only part of that supply chain. We can't drive projects. We have to be a contributor in the project. OEMs and other industrial supply chain partners, very directly relevant. Knowledge-based partners, universities with key knowledge that we can integrate into coatings, develop better coatings for the future, also very critical to that. And just a bit of a track record, we've got multiple collaborations historically, but currently we're in 3 FCH-JU projects. We've just started an FP7NMP, which is more about catalysis. We're in a multi-partner ITN, again focused on catalysis and sensing. And at the moment we're in 3 UK technology strategy board projects, so we're very, very active in collaborative research. But yeah, if there's anything of that strikes a chord, you want to talk to me, I'd be more than delighted to try and give you some more information. But thanks for your attention.
Thank you very much.
Good evening, everyone. So I've prepared a short presentation, and as Alex wants, 4 slides, and I hope that it's enough for your motivation to collaborate in our common project. Maybe found it in by Horizon program. I'm coming from Technical University of Ostrava in Czech Republic, and I'm representing of two laboratories which are focused on solving issues around implementation of hydrogen technologies in many platforms, system, and so on. Our university, the third biggest university, technical university in Czech Republic, significantly is located in third biggest city in Czech Republic. Was founded in 1839. Today we have around 22,000 students, around 6% of international students, and we are equipped with 2,000 employees, researchers, and additional staff. Centre ENET, Energy Units for Utilization of Non-Traditional Energy Sources, was founded in 2010. It's a research center, if you want, excellent center, which is focused to research of using of non-traditional energy sources, and we have around 90 employees, 90 researchers, with budget around 3 million euros per year, and now we have infrastructure for next develop of our activities. Project as a center of excellence is oriented to development, implementation of technology in research center in close area where we want to test it non-traditional sources, for example hydrogen technologies. As I said, I'm representing two laboratories as are a part of ENET Center, Laboratory of Hydrogen Technologies, and a Laboratory of Fuel Cells Application. Head of second one is here, Professor Horak. Our laboratories are focused to preparing of prototype devices for energetic system, which are equipped by fuel cells technologies, electrolyzers, hydrogen technologies, if you want, and also we are focused to testing general hydrogen technologies for production of hydrogen and using or production of electricity in some system where we work. As I mentioned, we have two laboratories. The old laboratory is laboratory which are located directly in our university campus. It's a laboratory of fuel cells application. This laboratory was founded in 2004, and our first project was prototype for EcoShell Marathon, prototype of race car, as you see on the bottom of the slide. We have 3 prototypes which are testing in a real race in EcoShell Marathon. Another about our laboratory. Also, this laboratory is a laboratory where our students has a first touch with hydrogen technologies in our university. We use fuel cells and electrolyzers in close loop for using renewables, and we use hydrogen technologies in this lab for accumulation of electricity from renewable. Our another project are oriented for next education, mainly for education or motivation of students of secondary school. We prepare our new potential students for our university. As I said, next project was project Hydrogenics, the relative big project Wavemobile, which was oriented to construction of drive unit of electromobile, which we use fuel cells technology as a APU unit in this prototype car. The bigger one is Laboratory of Hydrogen Technologies. In this lab, we want to applicate what we learn from 2004, and we want to applicate in 10 times bigger ratio. We talk about application of fuel cells technologies around 50 kV, and we want to use for producing of hydrogen technology around 30 kV in equivalent 5 normal cubic meter producing of hydrogen. This laboratory is part of a whole Centre ENET, which we built in these days. What we want to do, mainly with you. As I mentioned, our research is oriented to application of hydrogen technologies in real life, real devices, real car maybe. We want improvement of application of low temperature fuel cells and low temperature electrolysis in the hybrid energetic system, mainly with relation with renewables or with syngas opportunities to use syngas as a fuel for fuel cells mainly high temperature fuel cells. We want using or producing hydrogen by the help renewable resources, applied research of high temperature in CHP. We want to research and development in the field of transformation, management and accumulation of heat or electricity from renewable and application in bar grids. Now we're finishing infrastructure of research center ENET, which is located in city center. We have unique possibilities to connect this center in distribution network of electricity and heat direct in our city. And we want also implementing prototype and other hydrogen technologies in our laboratories. On the bottom of the slides, you can see one of our prototype of our car. from project WaveMobile, our prototype of APU unit with fuel cells, and some picture directly from Centre ENET in Ostrava, where you can see our accumulating capacity in lead acid batteries, and also our output inverters. Partnership. What we are seeking here. We are looking for long-term partnership with university or commercial institution. We are looking for a partner for common cooperation in education or in exchange of students and researchers. And we also hope that we are active, involved to the research activities in program Horizon 2020. So,
Thank you very much, Daniel.
if you want, contact us. We hope that we find common point of interest, and we start with little project.
Everybody's details will be
Yeah, sure.
as well. So
Thank you.
we'll make sure. Thank you very much.
Tropical is a company that has been located in Athens, and over the years has been working with air conditioning and refrigeration for the last 20 years. 10 years ago it started dealing and getting into hydrogen technologies, and has been in the Hanover Messe for the last 10 years on the hydrogen group, and ever since has participated in more national Greek projects, and has been transforming electric vehicles into fuel cell vehicles on a project-by-project basis. Has transformed the scooters, research institutes in Greece fuel cell systems. Has participated in more projects every time, a little bit different one from the other. Was involved in a project that changed from animal manure they produced biogas in cooperation with universities and research institutions, and the biogas was driven to the reformate gas was used a system that Tropical built. We're basically cell system integrators. We are building generators, 1 kilowatt and 5 kilowatt hydrogen generators, and we have built a few generators from reformate gas, kilowatt generator, but not on a constant manufacturing basis. It's order by order, and so we have been dealing with hydrogen fuel cell technologies and the hydrogen vehicles for some years. As you will see in more projects. We have completed, I don't know if you can read them, projects which were European or national projects. I just read them. Research study on the absorption of hydrogen from nanomaterials for use on fuel cells. These first projects were in around 2005-2006, and they went on going. Renewable energy technology transfer network. There was a network that was organized. Complete fuel cell system for power generation using methanol as a fuel. Software design, model and realization of a hybrid polygeneration system which includes PV, wind, fuel cells, electrolyzers, hydrogen storage and desalination units. We have been dealing also with metal hydrides for storage of hydrogen. catalysts, a vital tool for the environment's improvement as well as the energy production, combined pyrolysis fermentation of biomass, a high temperature fuel cells for the simultaneous production of biofuels and green energy, development and application of novel bimetallic anodic electrodes for direct hydrocarbon solid oxide fuel cells, understanding microscale mechanisms in the cathode gas diffusion layer of proton exchange membrane fuel cells, fluorine substituted high capacity hydrides for hydrogen storage at low working temperatures. This was just completed the last year. This European project was completed, and now we completed the. We are participating in the European High Energy Power Laser Energy Research Facility in Greece. There we are going to cooperate as designers of a refrigeration cooling system for the high power laser that the European Union is trying to develop for fusion of hydrogen for the production of energy. Ongoing is this project, which is robot fleets for highly effective crop in Mediterranean agriculture. This in this project, we supplied the energy power pack for supplying energy to all the peripherals of the tractors. These are 3 tractors given by Case, the tractor manufacturer in Holland, and in cooperation with 12 other organizations, universities, and research organizations and other robotic companies. And we built the energy supply system, which consists of 1 kilowatt fuel cell, 2 lead acid batteries, 4 bottles of hydrogen for supplying the fuel cell. We built the controller, which we have built many years ago, but we are continuously improving it. And we also integrated a solar panel, which is positioned on top of the tractor in order to get power from the sun and charge the batteries. Whenever the solar energy is not enough, we add energy from the fuel cell. All this package was fitted to the front of the tractor, and these tractors are operating now, and the project has finished and they have done all the trials. This was a very interesting project. And in Greece now we are developing an experimental testing of innovative fully hybrid electric minibus with 0 emissions. This is basically, we're using here, we're not using fuel cells, we're using lithium-ion batteries because we try to get into this field also. Because now the lithium-ion batteries have the price, the cost has been quite low, and we see that the market starts asking for this kind of storage systems. And for the Horizon 2020, we have submitted with the group that we cooperated with for the robot tractors, with the coordinator of the Madrid University, the pest risks protection through integrated control and monitoring for agriculture and forestry. Protector is called the name of the project. So this gives you an idea of what we have done. I went too far away. How do we go back? Here are the tasks that Tropical, we believe, is able to accomplish. Modular hydrogen fuel cell systems, modular reformate fuel cell systems. We have worked in the past with, we've done projects and with natural gas and LPG, methanol and biogas. Fuel cell hybrid power vehicles, cars, scooters, trucks, yachts and buses. Hydrogen storage, on solid-state hydride tanks, customized fuel cell and hybrid smart microprocessor controller, customized lithium iron phosphoric acid, phosphoric battery packs for numerous applications, customized power electronic components, inverters, converters, and stabilizers. We have developed those in order to incorporate them into our fuel cell generators in order to lower the weight, the volume, and also the cost. And turnkey hybrid solutions, fuel cell and renewable energy sources. And now some proposals that we can give you in order to trigger ideas for applying for the Horizon 2020. We have come up with these proposals. Biomass plant fed with livestock waste, sewage, food waste and wood, centralized production of synthetic gas, biogas stored in tanks, certified pipe network for supplying biogas at homes and businesses, use on multiple natural gas pipe reformate, combined heat and power fuel cell system, producing electricity and heat for homes and businesses. This is actually the small we have been discussing with some companies in Europe to develop such technology. Actually, it is developed, but we can make it more efficient. And another proposition is the PV plant with generation, geothermal energy, all kinds of renewable energy, grid connection, excess energy on water, electrolyzer and desalination units, storage of hydrogen on high pressure tanks and water on centralized tanks, production of electricity and clean water depending on scale population, electric and fuel cell vehicles like buses, taxis, scooters and bikes. In pilot projects we have developed these technologies, and we have transformed the scooters into fuel cell electric vehicles. That was, if you want, please write down our email, because it's not written in in what they gave in the list of. It's simple. It's info@tropical.gr. We'll be more than happy to cooperate with any of you that you want in the Horizon 2020 projects. If you have any good ideas, we are here to. We specialize, usually we work with research institutions and universities, and we do the manufacturing, the hardware part of it, as well as the controller part for controlling the systems. So in these fields we can work very well.
Okay,
Thank you
very much. Thank you.